All right, so example number 4 here, we need to solve for the letter n. We need to get n alone. And so to isolate n, we can't do that when it's an exponent. We need to get that down below, which will require us to do a logarithm. So what I like to do, to use a logarithm. So what I like to do is get this thing kind of by itself so that we can take a logarithm and get that down. So I'm going to divide both sides by a here. R to the n minus 1. So now that I do that, I can take the log of both sides. Now, you could actually do log base r, because that would cancel with that, but you don't have to. So I won't this time, just because there's all these letters in it. Log r, like that. Now we can bring this n minus 1 down. So what have we done so far? Well, we just divided the a over so we could isolate the r, because the r is what has the exponent that we're after. And then because I want that exponent, I got to take a logarithm to get that exponent down. So that's what I'm doing here. N minus 1 is being times now this log. I don't know why I wrote 7, or was about to write 7. So I need to get, what letter am I isolating? N. Okay, so let's divide both sides. This is a times, so let's divide both sides by this log r onto this log of r. So log of all of this stuff is equal to n minus 1. And now all I need to do is add 1 to both sides, which looks very strange on the left here, because like, how do you add 1 to that? Well, you can't, so you just kind of have to, you just write it all out. Log of r plus 1 is equal to n. So that is your final answer. However, you could now combine those. You can go, well, this is log base r, and then add the plus 1. So that is another answer. And if we had taken the logarithm with, we just had log base 10. If we had chosen this log r to be like right there, if I put an r there and an r there, that would have canceled out. And then you would have this plus the 1. And it would have been done immediately. So choosing log base r is actually quite helpful. But that's not how I did it here, though it can be done like that. So I'll just zoom out. I don't think I wrote this answer as a possibility, so that's why it's kind of nice to do these videos, so you can see that that is an option. But we got one more to do. What letter again? N? Solve for n. Okay, so what I need to do is get this r alone so that I can get the exponent down. So the first thing I can do is bring this 1 minus r, I can multiply it up, and at the same time I can also divide this a down. So that's kind of what I'm going to do first. So I'm going to multiply the 1 minus r, and then I'm also going to put the a on the denominator. So you can start doing this stuff where you do multiple steps at once. 1 minus r, as long as you're putting things in the correct location. So denominators, so that can cancel with that, and that can cancel with that. So I have here, I've got an s, and then I have a 1 minus r, and I have an a on the bottom. So that's what I have so far. Now, I need to get this r alone, so I guess I can just subtract this 1, which looks very odd. S, 1 minus r over a, take away 1, equals negative r to the n. So with this negative, what we can do is we're going to kind of divide by negative 1 to get rid of that. We've got to divide all of that by negative 1. Which means we're going to need to negate everything here. Everything meaning these two terms. There's this big term here, and there's this term. So that will just become a plus 1. It's not actually helpful. If you don't want to write this, you could always say, well, I'm going to times by negative 1. So I'm going to times that by negative 1 and times that by negative 1. That might be another option because that negative will cancel with that. This will become a plus 1, and this, the negative is on the numerator, that will go with that, so it's just a negative s, 1 minus r over a. So that might be an easier way to do that, timesing by -1. So that, again, that becomes positive, and this asks you to choose where you want to put it. Do you want to put it out in front? Do you want to put it up top? Do you want to put it on the bottom? And so I decided I'm going to put it on the numerator. So now you can do log if you wanted to, both sides. So you need to, but you can do a log base R if you wanted to kind of make things a little bit easier. So that's maybe what I'll do for this one, just to change it up. Log base R. So R to the N, and then this crazy thing, S1, A1. Okay. So I chose log base R, so when I bring this N down, that this thing will now cancel. So N equals log base R negative S 1 minus R over A plus 1. Now why does that cancel? Remember, like for example, 5, this says 5 to the what gets me 5? Well, the answer is just a 1. This just becomes a 1. And so we had written down log base A of A. Any number you choose, if they're the same, they'll just cancel. So if it's an R and an R, well, they'll still cancel. That'll just become a 1. So that's why that works. So those cancel. This N turns into a multiply, and this is just basically a 1. This log base R of R is a 1, and then this is just log base R of all of that. And so if you take a look, you'll see that on the answer key, I don't have that part. I have the log R right there. So, but looks a little nicer when it's kind of condensed like that. So this is your answer. To recap that, I multiplied both sides by 1 minus R, so I brought that up top. Then I divided by A, which is there, leaving me with just this 1 minus Rn. So I subtracted the 1, divided times everything by -1, so made it a positive, and made this a negative S. And then did log base R on both sides, which canceled out, and this N became a multiply. So this became an N times 1. So that's it. 2 questions that are completely different than what we've ever done, but they had to use logarithms to isolate a certain letter.